Let's do this. First thing to remember, these are your addition and subtraction formulas for sine. When you break up sine into a sum or a difference, it's always sine, cosine, cosine, sine. So the sign of a sum of angles for sine is sine, cosine, cosine, sine, with a plus in the middle, because I remember S for same. That's why this and this are the same. So for the sign of a difference of two angles, it's sine, cosine, cosine, sine, but a minus in the middle, because I remember same, so this and this are the same. For the cosine of a sum or difference, cosine is always cosine, cosine, sine, sine. But since this is not S, this and this are different. So the plus gets a minus in the middle. And then for cosine of alpha minus beta, it's cosine, cosine, sine, sine. So this minus becomes a plus. So using those formulas, we go to work. So anytime you see cosine, cosine, sine, sine, I think, oh yeah, that's a cosine formula where you've either added or subtracted. Since this plus, this would be a minus. So you can rewrite this in terms of the difference of two angles. So it's the cosine of 25 degrees. All of this, since I see sine, cosine, cosine, sine, I'm going to rewrite this because multiplication is commutative. This just becomes this, I can switch order. And this becomes this, I can switch order. So now I have sine, cosine, cosine, sine. But it's the sine of this angle minus this angle. And so it's -5, but since sine is odd, a negative can pull out front. Well, then if you have the sine of alpha is -5/13, don't forget sine is y over r, so that's telling you y and r, and the tangent is positive. Well, first off, notice that what we're trying to find is the sine of alpha minus pi/3. Well, the first thing we can do is we can apply the difference formula and rewrite it like so. Sine, cosine, cosine, sine, with the same sign in the middle. But cosine of pi/3 and sine of pi/3 are just on our trig hands, right? So that means, since they're on our trig hand, that means that this is actually the sine of alpha. Well, the cosine of pi/3 is 1/2 minus, and the sine of pi/3 is the square root of 3/2. So now our original question of what is this just comes down to, can you figure out what this, what this and this are? So can you find the sine of alpha and the cosine of alpha? Well, guess what? They already gave us the sine of alpha. So sine of alpha is -5/13. So really, the only thing left to do is just find the cosine of alpha. And so we need to draw a picture. Anytime in a math or science, you should be drawing a picture. So we need cosine. Well, since sine is this and cosine is positive, sine over cosine must be positive. Its tangent's positive. And since this is negative, they both have to be negative. So since sine is negative, cosine is also negative. So if sine is negative, it was going to be in one of these quadrants. But since cosine is also negative, it must be in the third quadrant. So I draw my picture where I open up my angle into the third quadrant, and then I run to the x-axis and make my right triangle. Remember, you're always running to the x-axis to make your right triangle. And so from there, I label my y and r, and I need to find x. Using the Pythagorean theorem, I get that x is plus or minus 12, but again, we said that the cosine was negative, and since cosine is x, that means that x is negative, so I get -12. Thus, the cosine of alpha is x over r, means that the cosine is -12/13. So that's what we had before. Plugging everything in, we get that the sine of alpha minus pi/3 is just this. All right. For 19, it tells us that alpha and beta are acute, so that means they're both less than 90. And they tell us some information about alpha. And they tell us some information about beta, which I colored green. Whoop, that is not the same color green. Which is, oop, that's not even the same color green. What color green did I use? Maybe this one? No. Can't tell what color green that is. Is it this one? Yeah, okay. So they gave us this information, this about cosine, this about sine. Since cosine is 4/5 for alpha, that means that I know x and r for alpha. So I come over here and draw my picture. Well, since alpha is acute, that means it's somewhere in the first quadrant. And I label my x and my r that I know, and I now must find y. Using Pythagorean theorem, I get y is plus or minus 3. But since they tell me it's first quadrant, since y is less than 90, that means it must be over here. Actually, not only that, it needs to be between 0 and 90. So to be acute, it must be between 0 and 90. It can't be negative. That would just be kind of weird for the proper definition. So for alpha, I know my x, y, and r. Then we come over here, and if the tangent of beta is 8/15, that means y over x is 8/15. So I draw my picture in the first quadrant. I run to the x-axis. I label my x and y and solve for r using the Pythagorean theorem. And since r is always positive, I know that r is 17. So now I know x, y, and r for beta. So now I'm ready to answer their questions. The first one is, what is sine of alpha plus beta? Well, I know that sine, cosine, cosine, sine. And since it's an s, I remember same, so it's a plus in the middle. And then I just read off of my info. So since sine is y over r, I know it's y over r is what goes here. For cosine, here the cosine of alpha is just x over r, so that's why what it is here. We do the same sort of thing for beta using this information. And we get 77/85 when it all comes out in the wash. Cosine of alpha plus beta is cosine, cosine, sine, sine, with a different middle sign because it's not the same. It's not an s here. When we use our information for cosine, we find these two. Use our information for sine, and we find these two. And we get 36/85 in the end. Double check me on that. But then, if this is cosine for part C, we can do cosine inverse to find out that reference angle in the first quadrant. If we do tan inverse of this, we get this in the first quadrant. So if those are our two angles, and you add them together, the sum of alpha plus beta would be in quadrant 1, because it would be approximately 64 point some business, 54. Yeah. Okay. Does that make sense that sine and cosine should be what they are? Yes, this is obviously less than 1, but cosine should also be positive, so that also makes me happy. So yeah, everything's great. Then we look at 71, definitely a problem and not an exercise. So they say, can you simplify this? And they end up giving you the answer is what it should look like. And so for this one, when you simplify it, we end up breaking this up using our identities. So the sine of an angle plus an angle is sine, cosine, cosine, sine. But remember, we've got that b on the outside, so we want to be careful and use these parentheses so that after you break it up, you distribute the b through to both, and that's why there's a b here and here. So then that means your original thing, P of t, is equal to this chunk plus all of this that you just broke up. But then that means if we look at these two together are really a plus b cosine tau times sine. And this is just b sine tau with cosine w. So if I let this be a and all of this be b, I can rewrite my p as a sine plus b cosine. And we're going to leave it there. I'll explain part B in class. Have a great day.